Hi guys, today we're going to do a simple parametric portal frame in Grasshopper with Karamba. So we can parametrically change the portal frame. We can get the moments and we can get the deflected shape. And a reminder that you can get more tutorials like this at our website. And you can also download the scripts if you prefer rather than building them yourself from the videos. And feel free to have a look at some of the other services we offer, including model conversion, reinforcement, visualisations, etc. Alright, so I'm going to start off by defining the points at the edges of the portal frame. And as usual, I'm starting off with a point, which I'm going to set to 0, 0, 0. That just allows me to move the origin point later if I need to. So the next thing I want to do is split that point up into its components. And I want to draw the next point, which will be the hip. So I want to add a slider, number slider, and add to the Z direction. And I'll just set this up because Karamba uses meters, sorry. So I'm going to set this to a maximum of say 20 meters. I just made it a real number there. It could be anything, but for simplicity. So I can actually call this height. Then I'm going to remake that point, or the new point, with the same X and Y but the modified Z. So now we have, no, and I'll change it to something. So I'll change it to say 10 meters, 10 meter high wall. So I've got 2 points. Number 1 and number 2. Now we can obviously create a line, which is the first column of the portal frame. Now the next thing we want to do is I'm going to define the other column on the other side. So the easiest way to do that is to move what we've already got. Now I'm going to do this one point at a time because it's going to be easier later, but I could grab both of those points straight off. But for starters, we'll just move the original point. I'm just going to copy and paste this slider, call this width, and then I need a vector, so I'm going to create a vector and I want it to move in the X direction. So that's the transform vector. So now we have our location of our other column on the other side of the portal frame. Now I'm just going to copy this because I also want to move the other point. So now that will control the top and the bottom of that column. And in fact, we can set up a line easily between these two again. Now the last bit is to create the top of the portal frame. So I'm going to make it so it's always equal. So I'm going to get the X component of that second column location, and then I just want the average. So if I add, this is just a very simple thing, but if I add the X of both of the points and then divide that by 2, Then I've got 5.5, which is halfway between 0 and 11, so that makes sense. And I want another slider, so I'm just going to copy and paste this one. Call this roof height. So now I need the Z value of the top of the portal. I already have the Z value for the top of the columns, so I'm just going to add the Z value at the top of the columns, which is this, to my slider. Now I don't need it anywhere near as much as that. I'll probably go 3 meters extra. So now I've got the Z value. So if I make a point out of the X value, which I got before, and the Z value, you can see that that is the top of the portal frame. And just for completeness, I'm going to make that Y value consistent. So if I move that point in the future, the portal frame will follow it. And again, I can make lines for these. So I've got this point and this point. And I have this point and this point. Pays to do these in the right order because it's going to help later when we start manipulating the lines. There are shortcuts you can take, but it's best to do it this way sometimes. Now we've got all our points of the portal frame. I'm just going to rearrange them slightly so that we've got first line, second line, third line, fourth line. Okay, to get that into Karamba, you've basically got to go and assemble a model. That's the main component. That's going to need some inputs of points, elements, supports, loads, etc. So we've got to give it most of those inputs. So I'm going to start off with points. I'm just going to collect all the points into a point component. So we've got our original point. Now I'm just holding down Shift to add our second point. Our third point was the top of the roof, so holding down Shift, I'll add that as well. Third point is there, add that. Fourth point is there, add that. So now we've got, that represents all our points. Put that in. Still needs more information, which you would expect. The next part is element. For the element, there's a handy component that comes with Karamba called line to beam. There it is. That turns lines into elements. So I'm just going to collect these lines into one component before I do this. Put those in. We've already got elements in there, so I could give them colors, etc., but for the moment I won't. So it's already got a basic model in there. It doesn't have supports though, so I'm going to add some supports. And I'm going to make it all fixed. So can't move in XYZ, can't rotate in XYZ. And it needs to know which points to make supports. So I'm going to make it the first point and the last point, which was that one, I believe. Yep. So now we'll have two supports. Put that in. Okay, the next one is load. So I'm going to grab a load. I need a vector for that, so I'm going to make a vector from XYZ. And I'll just put a panel up here so we can adjust it later. I'm going to make it in the Z direction, minus 10 kilonewton meters, 10 kilonewtons per meter, I should say, in the Z direction. I'm just going to make it a gravity load. Actually, yeah, okay, I'll leave it like that. It'll be load case 0, so you can add multiple load cases later if you need, which we will. Put that into load. Okay, the next one's cross section. So I'm going to use this component. There's a number of ways to do this. There's a few ways of selecting sections, and you can even make your own section. I'm going to cheat a little bit by using this method. Just because I know exactly what I want. But just play with some of these components. It's quite easy to select or find sections. Now I've put that in the wrong spot. There we go, I've got a cross section that I want. Put that in there. Lastly, I think I need material. That should be a minimum to get the model. The model's already working, but we want a section size in there and a few minimums. So I'm just going to put a material selection. And again, I know what it wants, but there's different ways of doing this. But if I put that in, I know it's going to give me steel. Okay, so now we have our Karamba model there. Now we need to see some results. So the first component I'm going to add is, we've got to analyze it, which is analyzed there. Got our model, we're going to just analyze it. Okay, that's just worked. So now we want to display the analyzed model. So there's a component called model view. Whoops. There it is. And already you can see a deflected shape. So obviously all restraints are fixed. So that would be the deflected shape you'd expect for a gravity load for a portal frame with everything fixed like that. Obviously we can play with the scale of the deformation. And moving away from just line work, we can also add in a 3D rendered version, which is called beam view. And we don't plug in the original model into this, but we put in the rendered model, and that will show us the actual eye section that we've chosen in the deflected shape. So that didn't take long, and that's got a portal frame analyzed in Karamba pretty quickly. We can obviously change all our dimensions parametrically. we've got our deflected shape, which we can amplify the deformation as we need to. We can also see some of the forces. There we go. If I scale that down a little bit, that should look familiar to most structural engineers. That's the MY, and that does look a bit funny because it's the deflected shape. So the axial load, if I use the original model, that would make more sense. You've got slightly more load axially as you work from the top down. It's just purely gravity load. And that's the moments not using the deflected shape. Now the last thing I'll quickly show is obviously gravity, while it's useful load case, one of the most important things for a portal frame is the wind load cases. There'll be quite a few in normal portal frame design. So let's try and put that in. And actually it's quite easy because we've already got, we'd set it up with a gravity load in the Z direction downwards. So if I disconnect that and I change this from a gravity load to a uniform line load, oops, let's go down a bit, give us some space, and I want the vector to be in the X direction. I'll leave it as -10, that's fine. So this will be the deflected shape due to wind. Now I'll just adjust the deformation down a little bit and the scale of the forces, but that should look logical. With a fixed portal frame, with wind acting in the negative X direction, those moments look correct to me. It's interesting that the moment is 0 here, but that will actually be the case because you're loading up, because it's completely mirrored, you're loading up both sides of the portal frame, and all the reaction will end up coming out at the base of 2 frames effectively. So that is actually correct. In the normal case, and you'd need to refine this more, you would add, say, a big load on this face, roof loads which may vary based on the distance from the edge of the building onto those, and you can do that with beam IDs here. So you can give each element a different load, or you could split this element up into multiple elements to give it different loads at different locations. Then you wouldn't see a 0 moment at that peak. So yeah, that's just a very quick demo of a portal frame, all parametric in Karamba, and it only took me, I don't know how many minutes, not very long at all. So hopefully people found this useful. Give us a like if you thought it was, and I'd appreciate any subscribe as well if you'd like to see more videos like this, or if you have suggestions or have questions or other demos you want to see, let us know in the comments as well, and we'll get it on the list for things to show people. Alright, thanks guys, and I'll see you in the next one.